Okay, so now let's start with the student response section. Starting with question number 16, it asks us to find the derivative of this function, which is y equals x over 3 power x. So in order to solve this question, we must first identify which skill are we going to use in this question. That will be the quotient rule. So what is the quotient rule? The quotient rule states that g times f prime minus f times g prime over g squared will give us the derivative of this function, and we only use the quotient rule in case we have fractions. Okay, so now let's start first identifying the values. So what is g here? Let us first identify what is f and what is g, what is f prime and what is g prime. Okay, so in the numerator this will be our f, and in the denominator it will be g. Okay, so now we've identified the first two values and variables, which is f, and that will be x, and g, and that will be 3 power x. Now what is f prime? F prime basically would be the derivative of x, which is always 1, and g prime is the derivative of 3 power x, and that would be 3 power x ln 3. We will be using the exponential rule. I've explained it multiple times before, so uh, let's start plugging the numbers. Sorry, it's supposed to be g squared. Okay, so now let's plug in the values. So let's write the fraction here. We have g, which is 3 power x, times f prime, which is 1, minus, see here, f, which is x, times g prime, which is 3 power x ln 3. Okay, divided by g squared, which is 3 power x squared, and because we have power to the power, we will multiply the powers, so it will be x times 2, which is 2x. Okay, now we have one last step, which is simplifying this fraction. Okay, so this answer is correct, but since we're in grade 12, we must simplify it even more. We see that we have here 3 power x and we have here 3 power x, so we can take it as a common factor. So we write here 3 power x and then open parentheses. Let's write the rest of the values. So we have 1 and then minus, let's write here minus, we have x, and we have ln 3. So we didn't do anything, we just removed the 3 power x from the function or the fraction, divided by 3 power 2x. And here we have 2 of 3 power x, and in here we have only 1 of 3 power x. So let's remove one of them. So our final answer become 1 minus x times ln 3 divided by 3 power x. Okay, and this, I believe, yes, answers our question. This is the answer. Moving to question number 17. Let's start first with let's name this as A, and let me name this as B. Okay, so for question 17A, we will be using the chain. Actually, for both of them, we'll be using the chain rule. Okay, but for question 17B, I've already solved this in a different video. It's a bit too long, and to keep the video short, you can just look at the explanation in the other video. For A, let's solve it. So 17A states that they want the derivative of this function, f of x. Okay, so let us write here f prime x, and I forgot to write, we must write dy over dx in each step. Here, dy over dx, dy over dx. This to make this step is to make our answer perfect. Okay, and it's necessary too in the exam to write. So here we have f prime of x equals. In the chain rule, what we will do is we will identify first our outer function and the inner function. So the outer function in this case is cosine. So let us label this as outer function. Outer function. Okay? And for tan, it will be the inner function. Okay? Inner function. So basically in the chain rule, we will first find the derivative of the outer function and times it by the derivative of the inner function. Okay, so that being said, let's start solving question 17a. So what is the derivative of cosine? Basically, we said that the derivative of cosine x will equal to negative sine x. The derivative of sine x will be cosine x. And finally, the derivative of tan x will equal to sec squared x. Okay? Now, we'll actually use the first one, which is cosine x. So, the derivative of cosine x will be negative sine x. So, negative sine x. We won't touch the inner function yet. So, we'll write it the same times, or not, sorry, tan x. Now times the derivative of the inner function, which we said was the tan x. And here it is, the derivative of tan x is sec square x. Okay, sorry here. Now, I believe that sums it up. Now, let us move to, actually, no, we can simplify it even more. Because here, sine times, okay, no, let's just leave it like this, okay? For question 18, here they ask us to sketch the graph, okay? So it doesn't have to be like by scale accurate one-to-one. We'll just sketch a graph of the continuous function. So that's the first thing we have to know, is that the function is continuous of f of x with the given properties. So the properties or the given properties are basically the rules of the function or the graph that they want us to draw. Okay, so first of all, let us draw a graph here. Let's just make it, yeah, like this. Okay, so double derivative of x is greater than 0. What does this mean? We said before that f of x, okay, so this is the function. The derivative of it would be the tangent line, and the double derivative of x would be the concavity of the function. So is it concaving up? So that's positive values. Or is it concaving down? So it's negative values, okay? In this case, they said that the double derivative is positive, which means that it should be concaving up. Okay, so that is the first thing we have to know, is that the function is concaving up for both x lesser than 0 and greater, less than 2 and greater than 2, okay? And here they gave us another rule, which was they want the graph to be undefined at the point f of 2, okay? So how do we do this? Well, saying undefined is another way of saying differentiable or non-differentiable, okay? And we've revised the differentiability rules, which are, they are actually two rules. So one, function should be continuous, and two, function should have no corners and no vertical tangents. Okay, so after revising these rules, we can use any of these three rules, and we will use the second rule in order to make the function non-differentiable or undefined, because it's the easiest one. So here they told us that the function is concaving up for x less than 2, okay? So this, let's say that this is 2, the point 2. So any point behind that, x should be concaving up. So let us write it like this, see? Some students make a mistake of making the function like this, but that shouldn't be the case. It shouldn't go up because the function is going to reach 0 while concaving up. So let us draw it like this. It should be drawn like this. And then at the point 2, there will be a sharp corner, but again, you have to remember that should still be concaving up. So it should look something like this. Okay, and this is how the sketch should look like. And to be honest, Mr. Hayat told us that this would come in the exam the same way it is, so he wouldn't change anything. So just remember this drawing, which is at 2. It should look like something like this. Okay, so let's solve question 19 in the next video.